In section 6.2, we are looking at either confidence intervals or hypothesis tests for a single population mean, where instead of doing what we did in chapter 3 and chapter 4 with bootstrapping or randomization tests, we can use inference based on the t-distribution. In order to use the t-distribution, we need to have one of two conditions hold. Either our sample needs to be at least 30 in size, or, this is an or statement, our population should be approximately normal. We only have to have one of these as opposed to the last section where we had to check a couple things and they both had to hold. So it's one of these or the other. If we have these conditions holding, we can use the t-distribution for doing confidence intervals or testing. And in doing so, the t-distribution has something associated with it called the degrees of freedom, which we'll abbreviate as a df. For the cases that we will be considering here, the degrees of freedom in this section will be n-1. So we're just looking in example 6.2.1 at whether or not our conditions are met to use the t-distribution, and if so, what the degrees of freedom would be for that. So if I have a sample of size 10, that is not big enough, but I am told that my population is normal. So out of those two things, I do have one of them checking out. So yes, we have a normal distribution, so our conditions are met. And so our degrees of freedom would be 10 minus 1, which is 9. In part B, sample size 15 is not big enough and my population is skewed. That also does not check out. So here the t-distribution is not appropriate because neither of those are holding as far as the two things that we had to have one of them working. And then in part C, we have a sample of size 50. So we check out, we do not care about the fact that the population is heavily skewed. Our sample is big enough. So our n greater than or 30 condition checks out. And here our degrees of freedom would be 50 minus 1 or 49.